As folks are coming in, I think we'll just get started. Good afternoon, folks. First of all, welcome to reInvent. I hope you folks are enjoying your time here in Vegas. My name is Anil Kumar, and I'm joined by my colleague Dominic Devakaruni. We both are product managers for AWS CloudFormation at AWS. We are really excited to be here, and together we'll take the next hour and focus more on how and a little bit on why and what. We'll show you how to architect your infrastructure using AWS CloudFormation. We'll also show you how to use CloudFormation and set up a AWS code pipeline. We'll also show you how to continuously deliver changes to Stack as you make changes to your template. We'll show all this using a demo that Dominic will run through. But before doing all this, I would like to take an opportunity to actually show you some of the software release processes and the phases involved in software release processes, mostly enjoyed by our software application delivery folks. And we'll see how we can take some of those best practices and processes and bring to our infrastructure world and continuously deliver infrastructure. If you have any questions, we will take them after our session. Dominic and I will hang around a bit after the session, so please come and find us. If you want to interact with us further, you can come and visit our management tools booth in the expo area. Awesome. So let's take a step back and see what are some of the software release processes. At AWS, we believe that we have 4 major phases: source, build, test, and production. In the source phase, you basically write your code, potentially getting it reviewed, and want to keep somewhere in the version control tool. The next phase is the build phase. Depending on your platform, you kind of compile your code, run some kind of unit tests. Maybe you're building container images, etc. This is typically an important phase in the software application delivery. Taking a step further is the testing phase. Suppose you're building your system that involves a lot of tiers. You can integrate all those tiers, run integration testing. You can run other kinds of tests: load testing, UI testing, and penetration testing, just to make sure that your system is not vulnerable to outside attacks. And then we have this last phase, production, where your code is ready to be deployed in a production environment. Basically, you want to get your application out in front of customers. We also think about how you work through these phases in terms of level, if you will. The one that is many people are familiar with is the concept of continuous integration, where on every commit, your code is going to a central repository, probably getting tested and built depending on the setup that you have. Taking one step further is the concept of continuous delivery, where you have the idea of your code is built and tested, and now it's ready for the deployment. It can be deployed in a production server or a pre-production server or an integration server. Typically, continuous delivery involves a gating process for the last mile before deploying your code into the production environment. Then there is this concept of continuous deployment. The moment you check in your code, it's getting deployed to a production environment. This continuous deployment doesn't involve any manual or gating process. Our focus for today's topic is continuous delivery of infrastructure. Now, at this point, we have seen what are the software release phases and different levels that bind those different phases. Now, the question for us is, definitely, we want to take some of the concepts from software application world and bring to our infrastructure world. The big question at this point is, okay, what are some of the tools or processes that we can actually use to implement continuous delivery for infrastructure? There are actually 3 things you can start with. The first one is you have to treat your infrastructure as code. I'm sure many of you are already familiar with CloudFormation, and many of you are already using CloudFormation, but this is one of the most crucial steps. You have to start treating your infrastructure as code. The second thing that you want to do is to find a tool that can manage the workflow, that can bind all the different release phases that we have seen earlier. And lastly, you need to find a tool or a feature that can be part of the service, infrastructure as code service, or part of the workflow that can actually conduct some kind of test or inspect your changes before you roll out your stuff into production. In a few minutes, Dominic will show you actually how you can use a CloudFormation feature to preview changes before rolling out those changes into production. So these things are at very high level. Let's distill this further. You definitely need infrastructure as code. The moment you have a codified format, you enjoy several benefits. The first one is you can version it. Second one is you can share it with your colleagues for review. Third one is you can keep it you can actually share with your folks they can reuse to replicate environments. And the second one is you need a workflow so that on every commit, your code is getting built, tested, and deployed. You can do all this thing using these two AWS services. AWS CloudFormation, our infrastructure as code service, and our workflow service, AWS Code Pipeline. I'm sure you folks are kind of familiar with AWS CloudFormation, but let's take a moment and talk about AWS CloudFormation. So this is our infrastructure as code service. In a declarative fashion, you can declare whatever you want in a JSON format or a YAML format, and CloudFormation will take care of the provisioning and configuring part. Furthermore, CloudFormation will also take care of the dependency needs and the execution order of those resources, so you don't have to worry about those resources. Now these things are in codified format. You enjoy several benefits. You can version control it. You can incrementally update those source code. You can share with your colleagues for review. CloudFormation also integrates with development, other CI/CD and development tools, including AWS Code Pipeline. And of course, you don't pay for using AWS CloudFormation. So this year, we released some of the key features. I would like to take an opportunity to run through these key features. That's kind of beneficial for you to recap these features so that Dominic will have an easy time explaining you folks. The first one is the authoring. We are on a mission to improve the authoring experience in CloudFormation. So one of the crucial things that we did is provide you another option for authoring, that is YAML. I'll talk in a bit about these things. The second was ability to preview changes before you actually deploy your changes. We launched, earlier this year, we launched a feature called change sets. A couple of months ago, we launched a feature called Crossstack References. It allows you to flow your configuration value from one independent stack to another independent stack without worrying about nesting or without writing custom resources. We natively integrated with AWS Code Pipeline so that you can enable continuous delivery workflows for your infrastructure. And lastly, we kind of built a new abstraction called transforms. Using this transform, you can architect and model your serverless systems using AWS CloudFormation. Last piece is a little bit out of scope for this session. Dominic will talk a bit about continuous delivery. I'll just touch upon the first three ones. So we got a lot of feedback from our customers, how we can further improve the authoring experience. We launched support for YAML version 1.1. As you can see, YAML is more concise and readable with a lot less punctuation compared to JSON. It allows you to add comment blocks so that your code becomes a little bit more maintainable. And lastly, whatever we support in JSON is supported in YAML, so you do not have to worry much. It's totally up to you, depending on your preference, whether you want to use JSON or YAML. Apart from supporting plain vanilla YAML, we actually did two more things. We introduced something called shorthand notation so that you can express all the CloudFormation intrinsic functions in YAML in a much more concise way and readable way. Second, we launched a new intrinsic function called fnsub. Using fnsub, you can actually do basic string interpolation within the template. So fnsub will let you substitute values in a variable within the template. Let's take an example to recap all this. So this is an arbitrary user data that you would write in a JSON template. The same thing you can express in YAML using all the enhancements like this. As you can see, the code is much more concise. You can use fn sub to actually replace value for the pseudoparameter in this case. You can also use the shorthand notation to express base64 intrinsic function. So as you can see, it's much more concise and much more readable. Customers were asking for a feature that would allow them to do preview of changes before actually executing the changes. We launched a feature called chain sets earlier this year. Chain sets allows you to preview steps CloudFormation would take when you're updating a stack or creating a stack. I'm showing you a basic workflow of updating a stack, including chain sets. So we start with your original stack, and suppose you want to update this original stack. So you update your template. You use this updated template to create chain sets. Chain sets will be generated and will present you blow-by-blow information of what is going to be created, what is going to be modified, and what is going to be deleted. Depending on the contents of chain sets, you can make sure that those changes are in line with your expectation. And if you're happy about your chain set, the contents of the chain set, you can go ahead and execute the chain set. This will help you update the CloudFormation stack. So again, chain sets show you what resources will be created, updated, or replaced when you're trying to update your stack or create your stack. We launched a feature called Crossstack References. Allows you to share information between independent stacks. You can flow your configuration value from one stack to another. So basically, suppose you have a stack, you can support, I'll give you an example here, that will be much more easier to understand. You start with a network stack. Suppose you want to convey this VPC information. You want to relay this VPC information. You can use the syntax export : name : prod VPC. You can export this particular information. And you have app stack that would like to consume this piece of information. You can use import value intrinsic function to consume this information. So as you can see, it's a much more concise and neat way to export values from one stack, one independent stack to another without writing any custom resources, etc. Now, since we are on the topic of cross-stack references, I would like to touch upon the concept of nested stacks, actually. It's not a new feature, launched a couple of years ago. A lot of customers are using nested stacks to enable modularity. So the concept is you start with your parent stack. Suppose application stack is your parent stack, and using the resource type, AWS : CloudFormation : stack, you can have your child stacks, in this case, network resources and ECS service. Suppose you don't want to have everything in one template, but you would like to have one stack. So you can use this concept to break your template into multiple pieces and still manage it as one stack. So it enables, it improves composability and reuse of templates. So after launching Crossstack References, we were getting a lot of questions from our customers that, okay, what should I use? This is the scenario. Should I use nested stack or should I use Crossstack References? I would like to point out at this point is that it's important to remember that these are not alternatives of one another. You can use either nested stacks or cross-stack references, or you can have a hybrid of both the features. Totally depends on your architecture, how loosely coupled you want it to be, how tightly linked or tightly coupled you want it to be. So we thought we'll share some of the recommended use cases, advantages and considerations of considerations related to using nested stack and cross-stack references. We'll see where these feature fits in your scenario. Definitely, if you want to reuse your template, you don't want to put everything in one template, you want to break it up, it's a good feature to use. Kind of convenient to manage. You want to have only one stack. So it's kind of convenient in that way. And it also, that CloudFormation takes care of all the dependencies and creation order of these stacks involved. A couple of considerations here. The moment you use nested stack, you kind of increased your rollback surface area and even update surface area. So if you have a child stack and you kind of feeling the tremors of rollback, then it can flow into your other stacks, parent stack. So you have to understand before using nesting that the rollback surface area is wider in this case. So in case if you have a system that requires a lot of updates, then you have to reconsider whether you want to use nested stack or cross-stack references. And of course, if you are thinking of reusing template, you have to make sure that all those child templates are kind of modular in nature, kind of generic in nature that can be used across other systems. If you customize it, then you will only use for one system. The whole concept of reusability might be missed. In case of cross-stack references, you can use it to share common resources. As we saw in the previous example, you want to flow your VPC information, and you have your app stack that consumes that VPC information. If you have that kind of use case scenario, cross-stack references is a very good place to start with. You can also observe separation of concerns and separation of responsibility using cross-stack references. Network folks are taking care of network stack. App folks are taking care of application stack. The biggest advantage is that when you start using cross-stack references, you are kind of limiting your blast radius from rollback standpoint, even from update standpoint. So you have these independent stack. If you have a stack that is in a rollback situation, then it's just only that stack. It's not. There is no concept of parent stack or rollback flowing to your parent stack. A couple of things to consider. You have to actually take care of some kind of creation order. You have to create. You have to export the value before that value starts to get consumed. So that thing you have to take care of. The other thing is that if you cannot delete a stack that is exporting values and that values are getting consumed somewhere through import. So you have to make sure that before deleting that all the references are deleted rather, and then you can go ahead and delete. So these are the things that you have to take into consideration before choosing nested stack or cross-stack reference. I'm sure when you're designing your new system, you will be at a point where you have to decide whether you want to go for nested stack or cross-stack references. So feel free to dive deep and understand the benefits and the considerations that you would like to carry it. A couple of things I would like to highlight here. You can see all the values that are getting exported on console now. We have enabled that functionality. You can use API and CLI also to see what is getting exported. We'll also launch in a couple of days a feature where you can see what are the stacks and which are the stacks importing values. So you'll have that nice mapping. So that information will provide you a lot of visibility into what you can delete, what you cannot. At this point, I would like to invite Dominic. He will take you through from this point.
Hello, folks. Hope you're having a good day so far. Let's apply some of what we talked about in the way of continuous delivery and the importance of infrastructure as code and needing a platform to manage your workflow. And let's examine a use case and how you would apply both of those things. Let's look at a sample application. What we're going to look at is a microservices-based application. Let's deconstruct the application into the necessary AWS resources or CloudFormation's AWS resource types. Let's create CloudFormation templates based on your management needs, based on how you would like to group resources, how you'd like to reuse templates, and if different teams are going to manage these templates, you may decide you want nested stacks as opposed to cross-stack references if the application is managed entirely by one group versus a couple. So we'll look at some of that. Let's then look at modeling your continuous delivery pipeline for your application, the different stages of the pipeline, and how you would like to, how you would like your changes as you iterate on changes to infrastructure. How would you like that to flow into your various environments? And then lastly, you can codify your workflow. You can codify the way you set up your pipeline, the way you set up your stages, all in CloudFormation, So essentially, you can use CloudFormation to set up your continuous delivery pipeline that manages the rollout of your applications and your infrastructure. So let's kind of look at all of those together. The application we've chosen to talk about is available at GitHub at AWS Labs at ecs.graphArc.cloudformation. It consists of 2 interconnecting microservices deployed as ECS services, a very simple app, a front-end service and a back-end service. The application runs on a highly available ECS cluster deployed across availability zones with auto-scaling. So it's a nice package of different AWS services, and let's look at that architecture and look at deconstructing it. Here's kind of a reference architecture. It's a VPC across one region, deployed with public and private subnets, deployed in separate availability zones. You have a highly available ECS cluster managed by an auto-scaling group, an application load balancer to serve up incoming traffic to your ECS hosts, the application load balancer path-based routes for each ECS service, the front-end and the back-end service. And you have NAT gateways and an internet gateway to serve outbound traffic from your ECS host to your internet gateway. This is a very handy reference architecture that's on Git, and we're gonna use this to study. There's templates on Git that show you this application framework in a nested stacks approach. We'll take a slightly different approach here and look at how you construct this via Crossstack References and then deploy that into your pipeline. One last thing that I missed is there are CloudWatch logs for centralized container logging. Let's look at decomposing this into the AWS resources. We looked at the high-level architecture. Now, what is this made up of? What is this composed of, right? So in your network, you have, now this breaks down into a ton of AWS resource types for CloudFormation, right? You have a VPC, you have a pair of public and private subnets. You have, in your private subnets, you have a private route table and a default route that have an association to tie them together. In your public subnets, you have your NAT gateway and elastic IPs, and you have internet gateways as well. For your security elements, we've defined 2 security groups, one to handle the logic for inbound traffic to the ECS hosts, or rather outbound traffic from the ECS hosts, and one to handle inbound traffic to the load balancer. You'll also need a load balancer. In this case, we picked an application load balancer, a listener, and the default target group that's necessary. You'll need your ECS cluster itself with auto-scaling. I think the original templates use about 4 hosts in your ECS cluster. We can, as we look at the workflow, we can look to change those number of hosts and see how that flows through your pipeline. It also consists of a front-end service that handles web traffic and a back-end service that performs the computations. Each of the front-end and back-end service has a task definition and a target group and the role to register and deregister the tasks. Breaking this down into separate CloudFormation templates, you'll have a network template like you saw on the left there with all your networking resources. You'll have a security group template for your security groups, so that can be managed independently. You'll have your load balancers in its own template, your ECS cluster, and your front-end and back-end service. Nice modular separation so they can be managed independently. You'll need to set up your templates to flow configuration to one another. So your ECS components and your load balancer can be deployed in into your VPC. So essentially, you have 6 templates that we talked about. What you will need to flow configuration between one another is outputs from each template. You'll need a VPC that's part of an output of the first template, and all the other templates will refer to that VPC ID. So you'll need the VPC. You'll need public subnets, and the load balancer is created and deployed into the public subnet. So the load balancing template will need that value. You'll need private subnets where your ECS hosts are deployed. Private subnets will need the value of, the ECS cluster will need the value of the private subnets themselves. Your security groups, load balancer listener is needed by the front end template, and the DNS name for the back end template. So let's look at how you would potentially structure all of this. You can lump everything into one template. You can create one gigantic stack, but that tends to be a little bit of a management nightmare. So you'd want to either use nested stacks, where you structure one parent template, and as Anil pointed out, use the AWS : CloudFormation : stack resource type, and state each one of these templates, the network, security, load balancing, cluster, et cetera, as sub-templates, and create one microservice stack. It's important to handle a parent stack and all of its nested stacks as one grouped component and not treat them individually. You'll want to manage updates at that parent level. So what nested stacks allows you to do is have modularity and separate your templates, but yet treat the whole thing as one application. Or you could use Crossstack References. You could create individual stacks and then export values and use the function import value to import, to flow that configuration between those templates like you saw on the slide before. The difference with Crossstack References is that you'll need to manage the dependency of the creation order and the dependency of how these are created. With a pipeline, that setup is much simpler, because you can set up your pipeline to provision your stacks in order and the order in which they're created. Let's look at applying continuous delivery to this setup. Let's look at modeling a pipeline for this application. Now, this is just a sample. This will all be posted on our docs page, and feel free to work off this sample. You can automate the rollout of your infrastructure as you iterate on various components of your application, various components of infrastructure that supports your application. Your pipeline will trigger deployments and push changes through the various stages. What we have to enable the workflow and the flowing of infrastructure as code through the various stages is Code Pipeline. CloudFormation launched the recent integration with Code Pipeline. Code Pipeline itself enables continuous delivery for fast and reliable application and infrastructure updates. Code Pipeline builds, tests, and deploys your code each time there is a code change based on release processes you define. We've added built-in actions into Code Pipeline to deploy CloudFormation stacks, to update stacks, delete stacks, and also use change sets. So we'll take a look at that. This is a really neat integration that allows you to manage your workflow as code and then flow changes through your pipeline. Let's take a step back and look at how this aligns with release phases. Anil talked about the source phase, the build, test, and deploy. With CloudFormation in Code Pipeline, you have really source, test, and deploy. And the way we're looking at this is you have your templates in S3, Git, or code commit, and you check in templates as you make changes to them. You use CloudFormation to verify what impacts those changes are going to have as they go through your various stages using change sets. And finally, you deploy those changes either using just creating a stack, updating a stack, or using change sets to verify those changes before you make them. Let's look at, I took a shot at modeling a pipeline that that customers typically have in their environment, right? So in a lot of customer conversations, we've heard, hey, a network team sets standards and manages the networking components. The application teams then use those networking components and deploys into those VPCs, et cetera. That may not be the case for everybody, but we've set up, I've taken that kind of approach to modeling two separate pipelines. One's a network resource pipeline that can be managed at its own cadence. Within this pipeline, I've set up a sandbox environment and a production environment, both with its own VPC security group and load balancing. So applications can be deployed in each environment separately. Also model an application pipeline, slightly different, but here it allows you to iterate on your application code more often, separate than your networking components. You may want to make changes very rarely to your networking setup. You want your application pipeline to trigger more often. So you set that up as a separate pipeline with dev and production. A little bit of an eye chart, but I will go to the pipeline itself at code pipeline and allow you to see this in a little bigger, in a little bit higher resolution. But essentially what this is the network resource pipeline with a source stage. In this case, we picked S3. We've picked a dev environment that creates your VPCs, your security groups, and load balancers in order as those values from the VPC are used in the other two. Change sets then to preview changes before you push any of those changes to prod. A manual approval step that allows you to review and then approve any changes before it gets pushed to prod. And finally, an execution phase where the change sets are then applied to your prod environment. Similarly for your application, but slightly tweaked, is your source stage and always even with S3 Git, of course, and code commit, code pipeline watches for changes as they're checked in to these repos and triggers your pipeline each time there's a change. I've set up a dev environment, but I've also set up to run tests once your dev is set up, your dev environment is set up. And then this particular pipeline is modeled to clean up your dev environment once you're done with it, so you aren't charged for the resources or instances you provision. And once you clean up, you can then push those changes to production. Similar to what we did on the network side, you can create a change set and go verify the details of the change set, approve it, and push it to prod. The details tab on the slide there on the page in code pipelines takes you to CloudFormation to see the details of the change set. It'll tell you what resources are getting modified or replaced. So only expected actions are executed. And finally, changes are pushed to prod as soon as you make that manual approval. Manual approvals are optional, obviously, but highly recommended as it allows you to ensure that only expected actions are carried out. Now, this is where it gets a little meta. Let's structure your workflow using CloudFormation. So use CloudFormation to structure your workflow, manage your workflow as code, and make changes to it, and check that in as well, and manage your pipeline as code. So for this case, CloudFormation template to set up your pipeline. We have an S3 bucket to store the artifacts of the pipeline itself. So all the input and output artifacts are stored in this bucket. SNS topic to receive notifications, email notifications when there are changes to be approved on your pipeline. The pipeline itself and the various stages defined in your CloudFormation template, and any IAM roles that you may need. You need 2 IAM roles. One is to allow code pipeline to call CloudFormation on your behalf, and the other one is to allow CloudFormation to call the other services on your behalf. Ideally, you'd provision these roles in its own separate stack and have it managed independently. But for this example, I included it all at one. Kind of an eye chart. Let's look at a particular stage, the construction of a stage in your CloudFormation template. This is a code pipeline stage for your dev environment where you're creating a VPC, where it's being set up to create a VPC. So you give it a stage name. The action is to create your dev VPC. And then you have a number of properties there that describe the action configuration itself. You use, in Code Pipeline, you choose the deploy action and CloudFormation as a provider. We've enabled several action modes. Replace on failure is the action mode I've picked here. It's pretty versatile. It creates a stack if one doesn't exist. It updates it if it does, or if it's in a failed state, it just replaces it. The name of your CloudFormation template within your repo. And there's 2 options for configurations for parameters. You can either use a template. Wow, this works. You can either use a template configuration file that has a JSON list of key value pairs for your parameters, or you can state overrides with any parameter that you want to explicitly set for your stack that's being created. In this case, I showed you all the parameters here just as a reference, but what was essential for me to set for this dev stage was a dev environment and environment name, which I will use to tag to all my exports, like I'll show you in a minute. So that's a sample snippet. Let's take a moment now and walk through the actual templates themselves, and then take a look at the pipeline. Love these pretty Windows screens each time. What you're able to see now is a template that configures your network pipeline. I've sort of consolidated to, and I'll expand it as we go along. Parameters, what I'm basically sending this template is a name for the pipeline, a bucket where all my artifacts are stored, and the key for the actual artifact itself, and an email address to allow the pipeline to send you notifications when there are actions to be taken. As far as resources go, this template sets up an artifact store bucket, which is a simple S3 bucket, your code pipeline SNS topic with email protocol, your pipeline itself. For the pipeline, you have your artifact store bucket, and you have your various stages and the role that the pipeline will use. For the various stages, I have a source stage, as you saw in the slide before, a dev environment stage, and a prod environment stage. Source stage points to the S3 bucket that you pass in. The dev environment does 3 things. It creates the dev VPC, the dev security group, and load balancer. You saw a snippet of the dev VPC before, so let's look at the security group. Same as before, deploy CloudFormation as a provider. Your template path, I don't have any parameter configs here. The only parameter that this template needs is an environment name, so I'm passing in dev environment. And I set a run order for this particular action as run order 2. So it goes after your VPC. I do the same for your load balancers. Run order 3. Then I have a stage for production. I have several actions to create change sets for each of the components, for each of the templates. A step to approve those change sets and then execute. So let's look at create. Create gets you set up with the action mode here is change set replace, which creates a change set or replaces one that exists already. And you have your configuration file and your template path. The approval stage is a manual approval that AWS Code Pipeline has set up. And then an execution phase that has an action mode of change set execute that essentially creates that pushes your changes or executes your change set. The role that CloudFormation will use to execute actions on your behalf. In this case, we have a star permissions policy. You'd want to scope that down, of course. And your pipeline's role itself, where that you would provide code pipeline to call CloudFormation on your behalf. The application pipeline is similar. I'm not going to go into this in gory detail, but what I do have set up here is 4 stages. Your source, your dev environment, a cleanup and promote environment. I'm done with my testing. In a true scenario where you're making changes to the application code as well, you'll have steps in here to either build or test your application as well in addition to your infrastructure. So your workflow is set up that handles both infrastructure and application changes, which really saves you time. Cleanup and promote stage, as I mentioned, and then push to prod with an action here to approve change sets before they're executed. So now let's look at the pipeline itself. 2 of the pipelines are set up. Again, just to show you a larger view of what you've seen before. Your app pipeline has the templates being created in order of execution, and a cleanup and promote stage, and finally push to prod. Let me, at this point, take a minute to switch over to a video here that will show you how I make changes to my templates and allow those changes to flow through your pipeline. So give me 1 second. So this is the initial, once the pipeline is set up and you've checked in your templates into the S3 repo, or the S3 bucket, rather. The pipeline gets going with creating your VPC security group and load balancers. Obviously, I've sped through this video. It takes a little bit longer than 5 seconds. You can actually see the clock counter on each one of those steps. So. This is not as quick as this video shows that it is. Your change sets are created, and it prompts you for a manual approval. In this case, I got an email saying that, hey, your pipeline, you have an action to be taken. And at this point, you can go verify your changes and approve them. I wanted to take a look at what my So once my network pipeline gets set up, I wanted to look at what exports are what exports are available that the application pipeline, application stacks can consume. You have a number of exports here. All are namespaced with the environment and the name of the export itself. And you have your exports for dev and prod. Going back through the application pipeline, looking at the actions that are taken once your templates are checked in for your app. At that point, once your dev environment is set up, you'd obviously have other actions to deploy your application, test your application, ensure that it is working the way you want it to before you say, okay, I'm ready to push this to prod and clean up. Kind of sped through that here and moving through that approval step of cleanup. Change sets are being created for prod with a notification for manual approval. In this case, I want to go make sure that only expected actions are being carried out. So I go to my CloudFormation stacks for my prod stacks, and I look up the change set. And I can see the resources that are going to be created as part of this action. In this case, we're adding 5 resources, and that's okay with me. Same with the other change sets that are created for the front end and the back end service. I'm happy with it. Now I'm going to approve it, and it's going to move to the next phase, which is to execute those change sets. And once this completes, let's look at making a change to your infrastructure configuration and see those changes flow through your pipeline. I have a configuration file for my ECS cluster. I'm going to change the cluster size to 6. I'm going to change, this is a very simple, basic change, but just to show you how these get pushed through the pipeline. I'm going to change the desired count of my task staff. And for my front end and back end service, save those templates, put them back in my repo. And look at the changes cascade through my pipeline. In this case, I didn't want to clean up I apologize. Just wanted to verify that those changes were made. In this case, I didn't want to clean up my environment just yet. I wanted to run my application tests, make sure everything's working right. So I kind of stopped there, didn't push it to prod. I go to my ECS console just to verify that everything is working as expected. I do have my right number of desired tasks and registered container instances. So everything appears to be fine. All my changes have been pushed. So that's kind of a demo of how you push changes through your workflow. Set up your workflow and push changes through your workflow as you iterate on your infrastructure. So in summary here, just to close out, we've seen a way to handle infrastructure as code, how to set up your workflow for your infrastructure, different ways to compose your infrastructure with CloudFormation using Crossstack References and or nested stacks, how to provision your pipeline and deliver changes as you make changes to your environments, your templates rather. There are more sessions where you can gather more info on what we presented. DEV313 in particular is a more advanced session on code pipeline that includes an example application and making changes to application code that's pushed through, and that's tomorrow. The CloudFormation documentation page has several links that will give you more info about our code pipeline setup and how you can take advantage of the various features that we've built into our CloudFormation integration. So there's some links for you to consume. And that's it, folks. That's what we have here for this presentation. Thank you very much for listening to this, and please remember to complete your evaluation.